Hi friends, today we will discuss an interesting facts controller HPFC hybrid power flow controller. This is Dr. Reddy from REC. HPFC is a combination of DVRs and one TCSC. So this is circuit diagram of HPFC. You can see there is one series capacitor. There are two DVRs. This is DVR2 and this is DVR1. So DVR1 will have DC source, charged capacitor acts as DC source, inverter and injection transformer. I can control the voltage of the inverter by controlling the pulse width. I can control the phase angle of the injected voltage by varying the phase angle of the triggering pulses. So this concept is similar to booster in olden DC systems. So we will see that with DVR can compensate sag, it can compensate swell, it improves the regulation. So DVR will have a DC source, then inverter to reduce the harmonics, one filter and one injection transformer. So your voltage drop will be like this, injected voltage will be like this. These two are in opposite direction. So your injected voltage and IZ drop will get cancelled. So going back to DC transmission line, I will have a small DC series generator here. Instead of line impedance in DC line, I will have line resistance. So I have IR drop here and I have DC injected voltage, and these two will get cancelled. So the concept of voltage booster in DC line is now used in the form of DVR. This is block diagram of DVR. If you want to implement in hardware, you need one microcontroller to generate the pulses, and the pulses produced by microcontroller are of 5 volts. They are amplified to 10 volts and they are given to the device of the inverter. DC source can be a battery or it can be a PV source. If necessary, you can have a boost converter in between. So I am adding one voltage, I am adding one load at the load bus. Like at home, your tube light is on. When you turn on the heater, voltage across the tube light will come down. So without DVR, voltage across the bus will come down. With DVR, it will inject a voltage. It takes some time for this to find out the voltage sag, then inject the voltage, then bus voltage comes back to the normal value with DVR. So the second part of HPFC is TCSC, thyristor controlled series capacitor, which increases the steady state limit. So we have both real power and reactive power in the source. If you see the capability diagram of the generator, it gives how much megawatt. If you take a 100 megawatt generator, the real power capability of this generator is 100 megawatt and reactive power capability is 75 MVAR. But this line impedance will not allow this power to go from sending end to receiving end. Something like the teacher has knowledge and students need that, but the system is not allowing the teacher to transmit the knowledge to the student. So TCSC is one facts controller which will allows both real power and reactive power to be pushed easily to the receiving end. So power is V1, V2 by X sin delta, where X is XL minus XC. This XC is variable. I can vary the reactance using TCSC. So the difference net reactance comes down. When the net reactance comes down, real power will increase. So TCSC will have one fixed capacitor and a thyristor controlled reactor in parallel. With capacitor, phase angle control of current is not possible. but with inductor phase angle control is possible. So this circuit is a combination of inductive susceptance and capacitive susceptance, and net susceptance is BL minus BC, out of which inductive susceptance can be varied, and hence net susceptance can be varied, and hence net reactance can be varied. So by varying the net reactance, power that can flow from bus 1 to bus 2 can be varied. So we'll recollect the working of thyristor controlled reactor. This is the voltage. If alpha equal to 90 in a pure inductor, current lags the voltage by 90 degrees. So this is your current wave. Suppose if I delay and give pulses at 120, the duration of conduction will decrease. With 150, this is the duration. With 180, the current is 0. So if alpha is 180, current is minimum. Alpha is 90, current is maximum. So by varying alpha, the current can be varied, or reactance can be varied. So this is the concept of phase angle control in TCR. Thanks for your patience, and please subscribe to my channel Ramareddy Sakti. Thank you.